So this is problem 3.7 out of your book. Basically, we have a pulley and a man pulling a rope at B. And we know that tension that he puts in the rope is 60 pounds. And then the pulley, there's a rope that's connected from C all the way around to D around the pulley. So it'll have that same tension in the rope. And they tell us that from the bottom part of the rope is 20 degrees, and then between the ropes is the angle is theta. So this is a coplanar equilibrium problem because it's all just in two planes. So what we'll start with doing, just like we'll do with all these, is start with a free body diagram. And we'll do it of the pulley here. So there's our pulley. We have two forces. So we have the tension, and the tension is the same in the whole rope because it goes around the pulley, so we'll just call that T. And then we have one here that is T. And then we also have that TAB, which they give us to be 60 pounds. And we know this one, or let me see. This one's 30 degrees is the angle. And this angle is 20 degrees. And then this angle is theta. So with this one, so free body diagram, we labeled everything. We also have to do the coordinate system. With these problems, it makes your life just a little bit easier if you think a little bit about where you want the coordinate system. So for this one, let's see, we could do it along TAB. That could be helpful. I feel like going along one of these unknown tensions would be more helpful. Let's see. Not the best drawing. So I'm going to make the X there, and then Y will just be 90 degrees from that X. So I've just changed it up just a little bit to make our lives a little bit easier. So with these, we have the, some of the forces equals mass times acceleration. So some of the forces in the X direction, and here we're not moving, so that's 0. So some of the forces in the X equals 0, and also the sum of the forces in the Y direction equals 0. So for the X direction, the T is just going to be negative T. For that was the bottom one or whatever, the top T is going to be still in that negative X direction, but minus T, and cosine of theta, because we want that component that's along T, so that'd be the adjacent side. And then for the TAB, so then we have plus TAB, and we basically, see, that's 30, that one's 20. So the X is just, it's basically 10 degrees. So plus TAB cosine 10 degrees. And that equals 0. So the TAB we actually know to be 60 pounds. So we have one equation with two unknowns. Fortunately, we have another equation. So sum of the forces in the Y direction equals 0. Actually, I just noticed this one shouldn't have a hat on it. Sum of the forces in the Y direction, so we'll do that similar. So that first one, that bottom T, it doesn't have a component in the Y direction. The top T does, and that would be in the positive, so plus T sine of alpha, of theta. And then the TAB would have some Y component also. So we have, and that would be a negative, because it's going down below the Y, 60 pounds, or TAB, and that would be sine of 10 degrees equals 0. So there we have another formula that has T and theta in it. Basically what I would do first is just solve for T. The sum of the forces in the Y direction one's a little bit has a little bit less going on, so I'm just going to solve for this one. So T equals 60 pounds sine of 10 degrees divided by sine of theta. So then I can take this one. So that's equation 2. Let's see, this one was equation 1. But basically we can put 2 back into 1. So when we do that, we get basically negative t times 1 plus cosine alpha. And I'm starting out by just simplifying that number 1 equals negative 60 pounds cosine 10 degrees. I'll make those both positive. And then now I'm going to go ahead and substitute that t in. So the t is 60 pounds sine 10 degrees divided by sine of theta. And then that's times 1 plus cosine theta. And that equals 60 pounds cosine 10 degrees. So now I'm just copying that over to the next page, just for simplicity. So if you haven't noticed, we have a lot of sines and cosines, so we're going to have to do some cleaning up of this. So let's, I'm just going to start by moving the sine and cosine of 10 over to the right side and keeping the thetas on the left side. So that'll give us 1 plus cosine of theta over sine of theta. That equals 60 pounds cosine 10 degrees divided by 60 pounds sine of 10 degrees. And so the 60 pounds just cross out, so we have cosine over sine. So that would be the inverse tangent. So we've got basically 1 plus cosine theta over sine of theta, and that equals basically cotangent of 10 degrees. So what we need to do now is we need to figure out what to do with this, the cosines and the sines, because it's a little complicated. So what I did was I don't remember all these relationships. So I downloaded a trig cheat sheet. I'll actually include that with the videos, just so you can use that as a reference. But one of them in there is the half angle formula. So I'll do this different color. And for that, you have 2 cosine squared, I'm going to say alpha, that equals 1 plus cosine 2 alpha. So that could be helpful for us doing something with this 1 plus cosine of theta. So for us, we'll just say that theta equals 2 alpha. So that means alpha equals theta over 2. And then we're going to rewrite this for what we have. So 2 cosine squared of theta over 2 equals 1 plus cosine of theta. So this helps us out, gets us closer for sure. So now let's go ahead and substitute this back into our equation. So we get, is that 1 plus cosine theta? Now we have that as 2 cosine squared theta over 2 divided by sine of theta, and that equals cotangent of 10 degrees. So that helps us and gets us closer. We still need to reduce it a little bit more. One of the other relationships, if you look at that, is, let me put that in green, is the sine of 2 alpha equals 2 sine alpha cosine alpha. And so we'll do it again where we do the theta equals 2 alpha, because we're trying to do something with that sine. So we get, for us, sine of theta is going to equal 2 sine of theta over 2 cosine of theta over 2. So let's put that back into our equation. And here we're going to get 2 and cosine of theta over 2 times cosine, because it's just a cosine theta over 2 squared, theta over 2, divided by, and that sine of alpha is going to be 2 sine of alpha, or of theta over 2 cosine of theta over 2. This is nice, so our cosine of theta over 2, one of those cancels out, and we end up getting, let me put the other side, cotangent of 10 degrees. So the 2's also cancel out, so we basically get cotangent of theta over 2. So cotangent of theta over 2 equals cotangent of 10 degrees. So if we just take the tan of both sides, we'll get rid of that. And so we get theta over 2 equals 10 degrees. Therefore, we get theta equal to 20 degrees. So now that's part of the problem. The other part, and we'll have to go back to our previous equations. So we have the theta, I'll box the answer, and then we just need to substitute back into that t equation. So I'm going to select that. So copy, and here's our equation now, and we just found that theta equals 20 degrees. Verify, yep, it was 20 degrees. And so now we're just going to substitute that into this equation. So we get T equals 60 pounds sine of 10 degrees divided by sine of 20 degrees. So T equals, get my calculator out. £30.46. So there. So now we have everything.